Welcome again to the Things Academy. So today we are going to utilize all these skills and all the knowledge that we gained in the past couple of days. So we are trying to bring it all together. The sensor readings from the device level to the network management from the Things stack and the gateway operations with these hardware provided by Rock Wireless, and eventually want the data to end up in the cloud and to process it and to do interesting things with it. So before we actually dive in this tinkering, in this hackathon that we're gonna work on, I first have a one-on-one interview with Olivier Seller. And Olivier Seller is one of the inventors of the LoRa technology. So he's already been working on this technology for years and years, and he's currently working as an engineer at Semtech. I'm honored to have one more interview, and this time I have a conversation with Catherine Caruana McManus. She is one of the co-founders of Meshed, which is an Australian-based IoT integrator. So they're mainly focused on smart city applications. And during this interview, we're gonna learn how she utilizes LoRaWAN to provide value and to build a valuable company. So Catherine McManus, thanks a lot for joining the Things Academy. I'm very happy that you're here on the show. So Catherine, you are one of the founders of Meshed. It's an Australian-based IoT integrator. You've been involved in many IoT use cases, specifically focused on smart cities. So maybe you want to tell me a little bit about yourself and what your role is within Meshed.
Absolutely, thanks Lauren. So I'm a co-founder and I look after sales and strategic direction for Meshed more from a market and customer opportunity perspective. We're a small organisation, but we've been established in 2015 and have been passionate about LoRaWAN and the Things network for, since that time. And my background prior to being with Meshed was I was with IBM for nearly 10 years. I've got a background in telecommunications and in government. So for me, this is very relevant to build a successful business. We now have 70 local government authorities where we provide a managed solution around LoRaWAN using the Things stack, both the community edition and the enterprise editions. And we've been very successful in helping cities and governments with what we call low-cost data acquisition, and then helping them with the insights around that. So that's a little bit about myself. I'm a bit of a geek. Even though I started my career off in the back office doing coding, to be honest, it's been more the last 25 years, really front of house of sales, but in largely technology space.
Yeah, perfect, thanks. So 2015, I think that was more or less the start when LoRaWAN hit the market. So you've been really here since the early beginning. So can you give me some examples of the projects you're doing?
Oh, I'd love to. We've got a really beautiful one that we're working on at the moment. I live in a gorgeous area in Australia. It's called Southeast Queensland. So it's the southern part of the northern state in Australia of Queensland. And we've been helping Sunshine Coast Council with a project to help save turtles. So an interesting fact, turtle sex is determined by the temperature of the sand. So with global warming, what's happening is that the sand is getting warmer, which means that more males are being hatched. And so with LoRaWAN and with temperature sensors that we're placing at the beaches where the turtles come to nest and lay their, as well as combining with covers, so shade cloth covers to try to keep the areas cooler. we're helping the environmental scientists of the council and the environment authorities to understand more about the environmental conditions for these nesting areas. And you may think that these nesting areas would be in very remote parts, but they're actually not. The nesting area is in a local beach here called Shelley Beach, which is very well, people take their families, they have picnics down there. So it's always a challenge with smart cities around not just serving the people and being able to provide great places for people to go, but also trying to preserve the very vulnerable natural environment.
Yeah.
So that's
nice.
Probably not smart cities, but it's just a very nice one at the moment.
It's very interesting. So what do you measure then exactly? Is it the sand temperature or the kind of track turtles?
Yeah, so we're measuring the temperature of the sand and also the moisture content. So by wetting the areas, we can keep the sand cooler. So the city has got sprinkler systems that they're using to try to wet the sand, but of course it can't be too wet, otherwise the turtles won't nest. So it's a very fine balance. But the other great thing is the same council is not just using LoRaWAN and the Things Network for environmental monitoring, they're also using it for things such as smart waste in their very popular strip shopping centres and foreshore areas. They're using it for people counting. Mm-hmm. So the meshed end counter is very popular, and they're getting a lot of information on footfall traffic, cycle pathways, and so they can also understand more about how people are using space, and that's helping them inform around keeping the amenities clean, keeping the barbecue maintained, keeping the rubbish bins clean, and also trying to also manage peak times, particularly through the summertime, which becomes very, very busy for them. Yeah, so there's a combination of different use cases they've got there.
Yeah, interesting. So you already start giving some examples, but maybe we take a small step back. And so what are smart cities exactly? So how would you define that?
In my view, it's quite simple. It's about using technology and data to do things better. That's just the simple reality. And prior to being with Meshed, I worked globally in smart cities for IBM. I was their smart cities executive, and I worked all over the world in projects. And if there was two common themes that city leaders are trying to achieve with smart cities, it's about doing more with less. So they have a lot of assets, they're responsible for a lot of services, they have very limited budgets, so they have to be able to understand the efficiency of that service or that asset. So that's the first thing. The second main driver is really around supporting businesses and people to thrive, to live in economic prosperity and to be able to achieve their goals. So there's a big focus in smart cities around placemaking, to make sure places are working for people, around urban design and around accessibility, around mobility, and then also particularly for the traders or the shop owners, to ensure that they're getting the right support to attract people to come to their areas. Now, it's a very interesting situation with COVID-19. We did a very interesting piece of research, which was well recognised, not just in Australia, but also globally, where we aggregated millions of data points using footfall traffic across over 100 locations in Australia. Wow. These were places such as tourism hotspots or libraries or community centres, and we were able to see the immediate impact of the COVID-19 restrictions when cities had to close down on the immediate community from a social and economic perspective. So
So what do you measure
right
then
now,
exactly? Is it the amount of people or the traffic going through?
yes, yeah, we measured footfall traffic, and the way that the solution works is it actually counts people within a range, and it sends the data every 10 minutes over the LoRaWAN network. It's a Wi-Fi tracking device, a Wi-Fi counter. And so very interesting, and it's called the COVID-19 Pedestrian Index. And so cities now, particularly in Europe and all around the world, they're very concerned about the impacts of COVID-19. You know, how are we going to get economic recovery? How are we going to help cities be able to re-stimulate their economies? And so the Things Network, the great platform of the Things Network, is really helping cities to understand about where they can do target stimulus, how they can make places cleaner and safer, particularly when we have to do things like social distancing.
So they really have hard data whether certain measurements also have effect. Yeah, interesting. So as far as I know, these trackers work in such a way that they scan for mobile phones, because mobile phones have a certain beacon, whether it's a Wi-Fi or Bluetooth beacon, and that's the way how you count people. Is that correct?
It works by, we've built an algorithm, and what we do is we're able to information off smartphones, which is completely randomized and anonymized. We don't, for example, take any information around MAC addresses, but we've built an algorithm which is able to identify it is a unique instance within range, and then what it does is it adds up all the unique smart devices within the range, and it then shares that information every 10 minutes. So we're able to show number of people, and we can show per day, per hour, per 10 minutes. We can also show dwell times. So the length of which that particular person was within that range, and it could be a range from 5 meters to 50 meters, 360 degrees from a point. It could be on a street pole, or it could be in a library foyer, and it's also able to collect dwell times. And cities love that because they can look then at the average dwell time. There's a really cute application that one of the cities, the city of Perth, has been using their Wi-Fi devices. At Christmas time, they put up the different lights, the beautiful Christmas light displays down their main street, and each light display has a different theme. So over Christmas, they were able to understand which themes were more popular, or with things like lighting, and they also had food stalls. So it was very well done that they used the people counting technology to not just understand that people were going out to see the lovely Christmas light display, but they also used it to try to encourage local food stalls to bring a bit of to the event. So I think that's a really nice one.
Nice, great. So maybe before you round off, so you've showed a lot of interesting use cases and some nice examples. So, but how do you actually make money? What is your business model?
Yes, our business model is quite simple, but for some reason we're not sure why other people haven't really done it as extensively as ourselves in Australia. So what we do is we help our customers to provide network connectivity. So we help them install their gateways, their LoRaWAN gateways. They tend to be IP67 outdoor gateways, IP67 rated gateways. And then we provide it as a managed service. So we're able, using Multi-Tech, and we use Device Manager for Multi-Tech, we're able to remotely monitor the performance of the gateway. We do all of the software updates and the performance measurement around that gateway, and we deliver that as a service. So every one of our customers, they pay a maintenance fee per gateway per annum, And we also charge a base account management fee, which enables us to do network updates and network maintenance, but also to manage them as account. So our business is an annuity revenue stream, and we've now got just around about 100 managed service customers. The majority of them are still using the public work, so the councils are still able, we help them with sensors. We'll pre-configure sensors to the network, and we will send them sensors, and then the data is reporting to it. We've got a nice little platform. It's a data visualization platform, so they can see the data. But now we're starting to see more in the private network. So some of the other business model is where we get the annuity from the things industry subscription to the private network, connected devices. And that's things such as smart lighting control, water metering, or asset maintenance, where there's a service level agreement required well beyond what the public network can provide.
Yeah.
So it's probably three areas. It's what we call network operations and management. It's the data hosting of the data platform, and then it's the solutions, which is the sensors and the smart city solutions, such as the end counter, the people counting that we can bring in as well.
Yeah, perfect. Nice. So it's not really focused on one specific element, but you really focus on different elements and yeah, starting with the connectivity and providing access there. So to start off, to end this conversation, maybe do you have a last piece of advice for our students?
Oh, I'd love working with students, and I think that it's so wonderful that the students are participating in this program, because I do actually spend a lot of time with students and in the universities. We have lots of universities. So advice for students is, I think it's one thing to be passionate about technology and be deeply technical and understand how it all works, but you have to be able to translate the value of what you're doing to the customer, so they can actually see the value and then build the business case around that. So, I think just the advice to the students is creative thinking is really an important part of the Internet of Things. And making sure that you deliver, obviously, a service that is secure and reliable and flexible. But I think thinking at the back of your mind about the business application, that's very important. And then just translating that value to that. I think just enjoy yourself and experiment. And I think hackathons are a really great way for students to engage around the technology and to bounce ideas off different people. Technology, often you see the person coding and it seems a very, sometimes lonely space where people are, sitting there just coding away. But actually, the Internet of Things, in order for it to be successful, you must collaborate and you must share ideas with different parts of the organisation. Let me give you a good example. In a local government authority or a municipality, they have 4 different areas of their business. They'll have the people responsible for the assets. So there'll be the asset maintenance and the operations and the engineers. Then you'll have the people who are responsible for placemaking and economic development. They're the ones that are focused on making sure that the city is functioning well and people want to come to the city and they want to enjoy spending the time there. And then you'll have the people responsible for the services, things like the childcare centres and the aged care facilities, and making sure that people, I don't know if you have this in Europe, but we have a thing called Meals on Wheels. So we provide food for people living in their homes, elderly people. So that's the aged care services. It could be education and schools. It could be healthcare. And then you have the people who are responsible for collecting the money. So they're the people, within the administration part of the business, dealing with the rates, and the taxes and things like that. So for smart cities to be successful in the Internet of Things, it's important to be able to connect the dots And I think the great thing about some of the case studies I've shared with you today is that we may at one minute be helping the environmental scientists try to deal with the situation with the turtles, but the same data could be used for the people in economic development who are trying to understand how do we manage, the number of people that are going to that area, and what else can they do to get a better experience for them. So I think it's multi-dimensional.
Yeah. Thanks for sharing that. It's really interesting that you say it's not only about technology, but it's really about connecting different people, using your creative skills, and yeah, really bringing it all together before you start working on the technology. Great. So thanks a lot, Catherine. It was great talking to you, and hopefully we see more of you shortly.
Oh, fantastic. Thank you. Hope that was okay, and enjoy the rest of your summer. And if any of them want to connect with me on LinkedIn, it's Catherine Caruana McManus. Lawrence probably has the details. Please ask any questions. I'll always give my time to students. Believe me, I love it, and thank you so much for letting me be part of this great initiative.
Perfect. Thanks a lot.
So let's start with the hackathon. So during the hackathon, we're gonna combine all the knowledge and skills that we learned throughout this whole week. We're gonna build solutions using LoRaWAN technology that matter. So you get a few points that you can take into consideration when building or when preparing your work. So this hackathon, we have basically all day to work on it, and tomorrow there are demos. So we have a jury coming in, and they will review the work you're doing. So you can do this hackathon by yourself, or you can do it in groups of 4, groups of up to 4, and the whole idea is that you create a full end-to-end use case. So make sure you embed all the knowledge that we derive from this course and build it into one solution. And I don't want you to just build a solution, I want you to think of a problem you see in society and to find a solution for that problem using LoRaWAN and using the skills that you learned during this course. So resolve an actual problem and eventually try to pitch it during a 2-minute demo in front of the jury. So make sure you communicate the problem, you are able to present it, and it needs to include a live demonstration. And eventually there's going to be one winner and there's going to be a prize to hand out. Best of luck today.
Hi Scott, thanks a lot for being back at the Academy. I invited you for during this hackathon session to give a little bit of context on what kind of issues you're facing in your field of work, to maybe inspire the students to have some nice cases they can work on during the hackathon. So Scott, you're very active in the agriculture space. Is there any issues, any problems you face that might support the students during this hackathon?
There's a lot of different things that we could try to solve together in this hackathon, but to kind of distill it down, one of the things, the themes that are growing are around microclimates. And so if you traditionally look at where you're at in your ag producing region, your current rural area, you might have one weather station that's out there. So there's a desire for farmers to get more microclimate, more localized weather data, what's on their farm. But even with that, whether it's an apple orchard or a vineyard or a cherry farm, you think about topology and the terrain. You might have a low area that might trap cold. You might have an upper area that might be a afflicted by winds. And so you think about even 100 acres or, a dozen hectares, though that area is going to have lots of little microclimates in itself. And so, we can't see a farmer putting 50 or $100,000 weather stations out there. So there's, with the power of LoRaWAN and, small amounts of small batteries and a small amount of power draw, we can gather simple temperature and humidity measurements, or maybe barometric pressure measurements, soil moisture pressure or soil moisture data that's more localized, maybe almost to the tree or plant level. But we have to bring the cost down, because if I have 1,000 trees, I'm not going to put $1,500 weather sensors on it, or even $100. So we got to bring the cost down. So the challenge is to really define the minimum amount of data points we really need. And so one of the use cases is frost. Frost is a bad thing. It happens in the late spring. We'll get out here in, outside of Seattle, in eastern Washington, we'll get frost that'll come through. And frost is created really when the temperature drops below freezing and the dew point hits that certain, the dew point and the frost point really converge at the freezing temperature, to where any type of moisture that might be condensing on the plants or fruit or whatever freezes. Now you also have to have a low amount of wind or no wind. So it has to be calm air. But that is huge for farmers to be able to say, you know what, maybe in a vineyard in this dip of an area, it's going to get about 2 degrees colder. And frost might form there, but it might not form higher on the hill where the actual weather station is. So the challenge is a small little sensor that is battery powered. So a little Arduino device with the temp and humidity will give you really 2 data points that you can pull out of that.
All right. Thanks a lot for sharing. I think this is a very clear problem. And I think LoRaWAN might be a very suitable solution for tackling this problem. So thanks a lot for explaining, Scott. And yeah, thanks a lot. Take care.
Good luck, everyone.
So Luca, welcome back to the Things Academy. So we're now in the midst of our of the week, and we are about to start our hackathon. So earlier this week, you told us about your work on protecting endangered species with your sensors that you install in wildlife reserves. So do you have some problem statement? Do you have some inspiration that students can use as a source of inspiration during their hackathon?
Sure. So here's an interesting idea for everyone at home. If you have a dog or a cat or an animal, you probably want to know if they're doing something they aren't supposed to be when you're not at home. For example, your dog sitting on a bed or a couch. So can you think of a way how to build a device and actually build a prototype that you can hide inside an object in your house to detect this activity, and then report it in some convenient way to the cloud or to your phone, so you can actually see what was happening?
Cool. Nice use case. So it's kind of detecting certain behavior of animals at home.
Indeed, or changes of stationary objects which relate to someone using them, so to speak.
Perfect. All right. Thanks a lot, Luca. So I give the challenge back to the students, and I'm very curious to see what everyone is building. Thank you.
Perfect. Best of luck.